So tonight we're going to do some quick tests on infrared reflowing using this handy infrared reflow station I borrowed from work. So stage one is to find your victim, which will be the Assault graphics card, and make sure it's nice and clean. Get all the gear off it and get it mounted in the PCB holder and apply some heat and see what happens. Like that. And then we need to take a measurement of the size of the package with a ruler. Oh, it's close enough. It's square, isn't it? So, what is it? It's about 40mm. Right, okay.
32.
32?
33.
33, right. So the shutters are adjusted with these knobs here. You can see below. Can we see below? Not really. So now I've adjusted the shutters so that they roughly correspond with the size of the device and centered the device under the center of the heater. We can use this knob at the back to bring the height down. So I'm just going to stick some tape over the surrounding area to protect it, and then we will cut a hole in it to expose the device, and it should be all good.
I have a knife.
You have a knife?
I have a knife.
Marvellous. Of course there's a downside, but we're going to do it by feel now because I'm not quite sure where the device is. I should be able to just push it down and see. It's here somewhere underneath this tape. But it's actually really quite sticky, this stuff. It's good stuff. It should reflect enough of the heat away to prevent inadvertent reflow action. I'll let you do the cutting since it's your board.
Well, this is discarded board.
I'll hold it straight, steady here so it doesn't move while you're doing it.
And then finish about that. I've bought some palm plants, which might take longer.
You just want to push it down around the edge. Just make sure that nothing's touching the chip. Right, that's good to go. Let's try it. I'm going to attempt to get a bit of flux in there with the very leaky flux pen. I'm not convinced you're really going to get a great deal in there, but better than nothing, I guess. Right, now we've made a mess and got loads of flux everywhere. Just enough to hold. We need enough for Kapton tape just to hold the probe.
So what about
A couple of centimetres will do. So we'll just make sure that the thing's centred again. And we can just adjust that left and right. Can't see what I'm doing here. There we go. That looks like it's central. Okay. And then we can remove the heating head. And we can tape the temperature probe next to the device with some high temperature tape. Alistair is very carefully preparing and making a mess. No, don't worry about it that much.
Yeah, I've tried to go through
We just need to make sure that some of the probe is actually sticking out the end and not too insulated, so we want to get a good reading of the temperature in the close proximity to the device. That'll do.
Need to be a bit more closer.
Nah, don't want to risk touching it. As soon as you touch the device, you apply some sideways pressure on it. It's just going to flow, it's just going to push it off sideways. That's close enough, because you know this isn't exactly a delicate piece of equipment. So we need to turn on the preheater, and we set the bottom heater to preheat, and we can also, I guess, set the top heater to preheat and let her warm up, and then take some measurements with the infrared thermometer wherever that went. There you go. Now, how on earth we're going to do this and get a measurement of temperature, I don't know, but theoretically one of the numbers on the display will be the top probe temperature. I think it's set to currently, and it's slowly cranking up. What are we measuring on the thermometer?
About 70.
70 or 80 degrees Fahrenheit or Celsius. This may take some time.
What do we get?
Okay, so if you want to crank up the right hand knob, which is the top heater, turn him to reflow all the way. Let's just go hot, and let's see if we can see any action. Maybe see some flux bubbling, like I said. I think the infrared thermometer's not really going to tell us anything useful there. I don't know, see if I can get a little bit closer. See, light is a problem as well, and there's a capacitor in the way, it doesn't help matters. It's quite dark under there, so you can see the reflection from the heater element above in the aluminium.
Yeah.
I think this is going to take a while. So we've decided we're going to stick the PlayStation 3 board in and give it a go. It can't get any more dead. So clean all the excess thermal goop off it, get all the dust off it, mask it off as before, and give it another whirl.
This is our Queen flight recorder.
Yeah.
So we've got two coils, one here and one in here, on the outside of an acrylic tube. And it's to record the flight of a Queen bee who's wearing a small metal disc on her thorax. Now as she passes underneath the coil, it changes the resistance in the coil, which sends a signal to the Arduino board that then turns on two series of lights here and fires a camera. So we get a photograph of the Queen.
So there's going to be a camera, or there is a camera.
There's a camera here.
Camera's over there. Oh right, so you're going to mount your SLR body in the top there.
Yeah, that will ultimately be mounted in there with a lens.
Oh right, and you can use the external power and trigger. Let's see.
Yeah.
And the Arduino can fire the flash off, and we can get pictures of which Queen it was.
Yeah, so that's
Presuming
the
there are
Queen.
multiple queens.
Yeah, that's the Queen. And then this gizmo here is a series of 6 channels, 3 of which are exits and 3 of which are entrances. And this is to record the passage of worker bees.
Right.
And it will count, because there's an infrared LED and an infrared detector underneath.
Okay.
So as the bee passes between the infrared lamp and the detector, it again changes resistance. And then through the Arduino board we can send signals to the
So that's not looking like standard Arduino, it's got a shield on top. What's that?
This is an Arduino Mega board with a
Right.
shield that carries a real-time clock and this card. So we can actually download all the
So
information
that's an
onto the
SPI
card.
interface, it's an SD card, so it'll be an SPI interface to the Arduino. So you can use that to record what timestamps.
Yeah.
Egress
Originally we
in.
were just relying on the time and date stamp from the camera,
Yeah.
but this is better.
Yes. Cool. Does it work?
Well, not yet, but it should do. It's almost there.
Presumably it's just software at this point.
Yeah.
And
All the
final
hardware
assembly.
works. All the hardware works. Yeah.
Yeah.
It's just
Nice.
coding, which I have not a clue about.
That's
why
what that man's
That's
for.
what my friend Paul is here.
Excellent. So, bit of progress on the electronics bench. Bracken is bolting stuff to the wall. Now he's drawing round the tools. Because that's really going to encourage people to put them back where they belong, isn't it? Rather than just everywhere, which is where they currently are. It's a start. Maybe we'll put a sign up. Put things back so you could find them again next week. And over here, Alistair is just finishing off fluxing underneath his GPU, having applied some reflective tape there to mask off all the other stuff. And I guess you're just
Just
going
about
to
now coming out through the bottom.
keep fluxing until it falls out the bottom due to gravity, and then we know we've got a good coating of flux. Well, probably a massive excess of flux underneath that part, and then we're going to give it a go on the reflow and reassemble the thing and see if it actually powers up and works. Fingers crossed. So we've locked the stage, taped it so it can't move, and we just did a bit more tape on the probe. We need to make sure the probe is pretty close but not touching the device. We don't want anything to touch the device when we're reflowing. Just tape it across there somewhere.
Is that close enough?
That'll do. Right. Some juice on. Turn the rear side preheater on. Bottom side preheater. And pop that down. Let's make sure nothing's touching the device from below. There's the nice and uncluttered around the device because of the heat spreader that bolts to the top part of the heat, where the heat sinks and the fans are, so there's lots of clearance around it. Looks good. Crank up the preheater, and now we wait.
It's not a finished project.
No.
See, that needs buffing to get
Trying to
good
put
job.
your finger on why it doesn't look metallic. I think that you should put your finger on right there.
Yeah, just use deeper. Yeah. Does it use metallic?
Well, I bought a quick
No, that's
dirty eBay
the
CCFL cold cathode fluorescent light inverter for £1.63 off eBay, and I've hooked it up to a dismantled 17-inch back panel off a monitor and a power supply, and let's see if it will light up. I've only connected one of the two tubes from each end because I don't have a 4-output inverter, but we'll give it a go. Hey, that'll make a nice light box. Not bad for £1.63. So it looks a bit bright around the edge but a bit dim in the middle, but it did come with a whole load of filters. There's this one, and they should potentially flatten the light distribution. There's quite a few of them. There's a weird silvery one, not quite sure what that's about. Some sort of circular polarizer, potentially. Oh, that looks dark. Weird. And then the next filter in the stack is this kind of diffused looking one, and look at that. Neat. And then the thing that goes on top is just protective film which is covered in fingerprints and looks icky. We'll keep that off. But don't quite understand the optics of this situation, but that'll make quite a nice light box or a nice sign. I'm excited.